How to create XRD plot in Origin. Whether you need good help, a genius writer, a brainy tutor, or a data wizard, Intuito for you has them all. It's like having a research dream team on demand.
Have you ever opened up a raw X-ray diffraction file and just stared at it? You know the feeling. It's just columns and columns of numbers. In this explainer, we're going to break down exactly how you turn that raw data into a beautiful, professional, publication-ready plot using Origin. I mean, look at this. On the left, you've got the before, a total mess of raw data that doesn't really tell you anything at a glance. And on the right, that's the after, a clean, clear, professional graph that tells a story. We're going to bridge that gap right now. And here's the deal. I'm going to walk you through this step by step using a real data set. By the end of this, you'll be able to take your own data and do this perfectly, all on your own. I promise.
Okay, first things first. Before we can even think about making a pretty graph, we have to get our data ready. This is the foundation for everything that comes next. You know, garbage in, garbage out, right? So let's make sure we get this part right.
So what does your data need to look like? It's super simple. Origin just wants a basic text file, you know, a TXT file. All it needs is two columns. Column 1 is your two theta values, and column 2 is your intensity. That's it. Nothing fancy.
All right, let's get that data into Origin. You're just going to navigate up to File, then go down to Import and click on Single ASCII. A window will pop up, you find your text file, and boom! Your data should be sitting right there in an Origin worksheet ready to go.
Okay, here's a tiny step that'll save you a huge headache later. The moment your data is in, label your columns. Just double-click on the headers. This little bit of housekeeping means your final plot will automatically have the right axis labels. It's a small thing, but trust me, it's worth it.
All right, our data's in, it's labeled. Now for the fun part. Let's actually craft the plot. This is where we go from just a basic chart to a figure that actually gives us some real insight.
So how do we make the plot? It's ridiculously easy. Just highlight both columns of your data, then head up to the plot menu, find line, and click it. And voila, you've got a plot. Now, it's a start. It shows the data, but it's pretty plain. We can do so much better.
To get that really professional look that you see in journals, we just need to tweak a few things. Go ahead and double-click the plot line. Let's make it black, because that always prints well. We'll set the thickness to 1.5 points. That makes it bold, but not clunky. And finally, get rid of the symbols on the data points. We want a nice, smooth, clean line.
Next up, the axes. Because we labeled our columns earlier, the labels should already be correct. Nice, right? I also really like to add light gray grid lines. Now, the trick here is to make them subtle. They should be just visible enough to guide your eye, but not so loud that they compete with your data. See? It already looks so much cleaner.
Okay, the plot looks great. But now for the really cool part. The part that's a total game changer. Instead of squinting at the screen trying to guess where the peaks are, we're going to have Origin find them for us automatically.
So here's the magic trick. You navigate to Analysis, then Peaks and Baseline, and open up the Peak Analyzer. You want to choose the Find Peaks option. Now the key here is to set a height threshold. This basically tells Origin, hey, ignore all that little background noise and just show me the real important peaks.
And just like that, Origin scans the data and bam! It instantly finds and labels a key peak right at 20.25 degrees. This is that moment where your graph stops being just a picture and starts becoming actual hard analytical data.
So who cares about these numbers, right? Well, you do. This is the whole point. Having these exact peak locations is incredibly useful because these are the fingerprints of your material. You can now take these values and match them against a database to figure out exactly what crystal structure you're looking at. All right, we have a beautiful, fully analyzed plot. We're on the home stretch. The last critical step is exporting your masterpiece so you can share it with the world. Getting it out of the software correctly is just as important as making it. Now, how you export really depends on where it's going. Think of it this way. If you're submitting to a journal, you need the absolute best quality. So you'll use a format like TIFF or PNG and make sure your resolution is 300 dpi or higher. If it's just for a PowerPoint or a website, a JPEG is totally fine. But a pro tip, always save that high-res version. You never know when you'll need it.
And there you have it. Would you just look at that journey? We started with that mess of raw numbers, and now we have this, a clear, analyzed, and totally professional figure that's ready to tell its scientific story.
So I'll just leave you with this final thought. Your data always has a story to tell about your material. The real question is your plot telling that story clearly? Thanks for joining this explainer.
And subscribe now for more amazing videos just like that. And don't forget to like, share, and subscribe to yours channel. Thanks for watching.